Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. Today we would like to present our group project, Student Performance Factors. Our team consists of 3 members, which are Auni Iriani, Nur Nabila Hanis, and me, Nur Aina Jiha. For our presentation, there are 6 parts: A1, A2, A3, A4, B, and C. Problem statement and objective. Problem statement. Create a prediction model to identify and analyze the key factors influencing student performance in Excel. For the objective, to see the accuracy of the dataset when we use the different algorithm. A1. Data acquisition and data understanding. Dataset information. The records in this dataset are related to a comprehensive analysis of factors influencing students' exam scores, such as study habits, attendance, parental involvement, and other elements related to academic achievement. As for the criteria of the dataset, instances 6,607, attributes 20. There are numeric and nominal attribute. The task is classification. As for the class attribute, we choose class exam score. Student will be categorized as excellent, good, or average based on their scores. As the source of the dataset is from Kaggle, and there are 3 articles that we use as a reference. Article 1, affecting students' academic performance, and Article 2, student performance classification, a data mining approach. A2, data preparation, selection, and cleaning. In the pre-processing tab, there are 6 steps that we need to do. The first step is numeric attribute. There are 6 numeric attribute. First attribute is hours studied, second sleep hours, third attendance, fourth previous course, fifth tutoring sessions, and 6th physical activity. The second step is nominal attribute. There are 14 nominal attribute. The first attribute is parental involvement, second extracurricular activities, third access to resources, fourth motivation level, fifth family income, 6 internet access, 7 teacher quality, 8 school type, 9 peer influence, 10 learning disabilities, 11 parental education level, 12 distance from home, 13 gender, and lastly 14 exam score. The third step is attribute with missing values. To apply it, go to the unsupervised attribute filters and replace missing values. This is the before we apply the attribute with missing values, and this is the after we apply the attribute with missing value. Fourth one is attributes containing noise. The attribute containing noise, go to the unsupervised attribute filters and remove useless. We use this filter to remove attributes that do not vary at all or that vary too much. 5 is attribute with outliers. There are 2 steps for attribute with outliers. The first step is go to unsupervised attribute filters and interquartile range, and the second is unsupervised instant filters to remove with values. This is used to determine outliers and extreme values. For filter remove with values, it is applied to remove outliers and extreme values. This is the before we apply the outlier, and this is after we apply the outlier filter. This is the before and after outlier to the extreme value attribute, but since the label for yes already 00, there is no need to apply the filter to the attribute extreme value. And the last step for A2 is save the file with the name file underscore clean. This is the sample of the data after the A2 was applied. For A3, data preparation transformation, there are 5 steps. First step is perform normalization. The data from A2 show an in-uniform and comparable data, so use sex code normalization. Normalize is a technique used to scale the numerical features in the dataset to common range. The purpose is to ensure that all features have similar scales and magnitude. Apply the normalization, go to preprocess, filters, unsupervised, attribute, standardize. This is the dataset after we apply the filter normalization. And this is all the attribute after we apply the normalization. Step is to perform discretization. Discretization is used to divide range of attribute into intervals. Discretization is the process of converting continuous data into discrete intervals or bin. This only applied to the numeric data. To apply discretization, go to preprocess, filters, unsupervised, attribute, discretize. This is the attribute before discretization is applied. This is the attribute after we apply the discretization. Next, we apply the discretization to 2, 6, 7, 10, and 15. And this is after we apply the attribute discretization. 1. Attribute construction. This step is unnecessary because the existing attributes are sufficient to perform well, and introducing new attributes may unnecessarily complicate. As for the fourth step, other specific processes also unnecessary because not significantly impact the performance. And the last step, we need to save the file with the name file underscore process. So this is the sample of data after we apply A3 to the dataset.
Next, we're going to talk about A4, data preparation, reduction.
In this slide, we're gonna explain about the reduced dataset, comparison of the result, and save file reduce. First, explanation of the reduced data. Reduce data to improve model performance by focusing on the most informative attribute. In record, we have to select attribute, pick info gain attribute, and select for ranker, and set to 10. Info gain attribute. An attribute evaluator that measures the information gain, which is the reduction in entropy, is helped in identify which attribute are the most informative or predictive or target variable. Method, we choose ranker. Such method used to rank attribute based on their score from the attributor. It sorts attribute from the highest to lowest score, making it easy to select the most relevant attribute. Here are the data that we got. Next, we're going to talk about comparison of the reduced dataset. Two different set of features. This is two evaluators that we choose. The first attribute is info gain attribute, and second subset eval. For the info gain attribute, we use mode ranker, and this is the data that we got. For the subset, we use method best first. That's the data set that we got. Info gain attribute ranker is chosen because it actively identifies and ranks the most informative attribute based on their information gain. This method is useful in the future selection and decision tree. For the next step, we have to save our reduced file, and here our reduced data, and this is our visualization reduced data.
Next, we move to the section B, Model Development and Evaluation. In this section, we will test our dataset on cross-validation 10 and 20, then percentage split 70% and 80%. As shown in this screen, K is equal to 10, meaning that our dataset is divided into 10 equal size full. So, the accuracy display 88.0413% and 11.9587% for error rate. And then repeat the same step for cross-validation 20. The dataset is divided into 20 equal size full, and we get 88.1933% for accuracy and 11.8067% of error rate. Next, in the Classify tab, choose percentage split 70, meaning that 70% of the dataset is used for training the model and 30% of the dataset is used for testing the model. The accuracy is 87.4367% and error rate is 12.5633%. Next, we choose 80 as the percentage of training dataset. The accuracy shows that 90.5775% and error rate is 9.4225%. Okay, so this is the result for J48 classifier. We can see that the accuracy for cross-validation 20 is higher than cross-validation 10. And the accuracy for percentage split 80 is higher than the percentage split 70. Based on the result just now, we can make a tree visualizer from the best result of cross-validation and percentage split. The high value of our cross-validation is K equal to 20. So, this is the tree visualizer. Next, for percentage split 70-30 is the best result based on our data. And this is the visualized tree. Next, the reduction method that have been applied. For reduction method, we select info gain attribute and ranker method. So, this is the 10 selected attributes from our data. Then, we repeat the step 1 until 4 using the reduced data. The first step, using cross-validation 10. Second, we change it into 20. The third step, using reduced data, percentage split 70% and 80%. For section B, classification, the last step is comparison for evaluation results of processed dataset and after dataset is reduced using graph in Excel. So, this is our result. And this is the graph of comparison of 4 test options.
C. Comparing different algorithms to see which algorithm works better for this dataset. J48 easy to visualize and data boost M1 improve accuracy. From the Classify tab, click Classifiers and choose J48. And the next data is we using classifier J48 for cross-validation 10. The accuracy is 88% and the error rate is 11%. Next, using percentage split 70% and 30. The accuracy for this 87%. The error rate is Next, we are using reduced file for cross validation. Hence, the accuracy for this 87%, the error is 12%. Percentage split 70-30, the accuracy for this 88% and the error rate is 11%. For the second classifier, we use AdaBoost M1. From the classifier type, click the classifier and choose AdaBoost M1. We repeat the same step but using AdaBoost M1. For the cross validation, then the accuracy is 84% and the error rate is 50%. Using processed file, percentage split 70%. The accuracy for this data is 83% and the error rate is 60%. With the same classifier AdaBoost M1, we are using reduced file, cross validation 10, and the accuracy for this is 84% and the error rate is 50%. For the percentage split 70-30, the accuracy for this data is 83% and the error rate is not 60%. This is the table that shows differences between J48 and AdaBoost M1. Using Excel, we plot the graph the comparison between J48 and AdaBoost M1. As you can see here, J48 is more higher than AdaBoost M1.
In conclusion, to review it effectively, we conducted data transformation, reduction, cleaning, selection, and model comparison. J48 consistently achieved higher accuracy compared to AdaBoost across multiple tests. It shows in the results that J48 is more accurate and efficient for this dataset. So, that's all from Group 4. Thank you.